Have you ever had to send a calendar invite to like 1,000 people? How about 10,000? It is a total nightmare. Today, we're going to break down a really elegant, serverless architecture that turns all that chaos into a smooth, automated process. So, let's kick things off with the big question. Right? I mean, seriously, what could go wrong? Besides, accidentally sending the same person 5 invites, or having half of them fail without you even knowing it, and then having absolutely no way to track who actually got invited? Doing this stuff manually at scale isn't just a chore, it's basically a recipe for disaster. And that's the exact problem we're going to solve. So, first up, the bulk invite challenge. We're looking at how to get away from a manual process that's just begging for mistakes and move to something that's built to be robust and reliable right from the get-go. Which brings us to our automated solution. Now, to make this all make sense, I want you to think of it as a digital post office, a super efficient automated system built with a few key tools that are perfect for the job. The backbone of this whole operation, this digital post office, is built on 4 key AWS services. We've got SQS, Lambda, SES, and DynamoDB. You put them together, and they create this perfect assembly line for processing invites. Let's meet the crew. First in line is Amazon SQS. This is our mail sorting room. Imagine thousands of invite requests all flooding in at once. SQS doesn't even break a sweat. It just neatly lines them all up in a queue, making sure not a single request gets lost and that everything is ready to be processed in a nice, orderly fashion. So, who does the actual work? That would be AWS Lambda, our diligent postal worker. Being serverless means it just springs into action when there's a job to do. It walks over to the SQS sorting room, picks up one, and only one, invite request from the queue, and gets it ready for processing. Okay, so our postal worker has the invite all prepped. Now it needs to be delivered. That's where Amazon SES comes in, the simple email service. Think of SES as the specialized, ultra-reliable mail carrier. It takes that perfectly formatted iCal invitation and makes absolutely sure it lands right in the attendee's inbox. And finally, we have what might be the most important part for preventing mistakes, Amazon DynamoDB. This is the post office's master logbook. It's a lightning-fast database that keeps a perfect, meticulous record of every single invite that has been sent. This logbook is the system's brain, its memory. All right, Section 3, the invite's journey. Now that we've met the whole team, let's actually follow one single invitation request from the moment it's created all the way to delivery. This whole journey is a really simple 5-step flow. It starts with a trigger, then we extract and check the details, we send the invite, we update our records, and finally, we do a little cleanup. Let's walk through each one. So it all starts here. Some other system drops a message into our SQS queue, into our mail sorting room. That message is simple. It just says, hey, please invite this person to this event. The arrival of that one message is the trigger that kicks this entire automated process into gear. Instantly, our postal worker, the Lambda function, gets notified. It grabs the message, opens it up, and pulls out the key details, who to invite and for what event. But, and this is the most critical part, before it does anything else, it goes straight to the DynamoDB logbook. It asks one crucial question. Have we already sent an invite to this exact person for this exact event? If the logbook comes back with the all clear, nope, no previous invites found, then, and only then, does the system move on. The Lambda function generates a standard, perfectly formatted iCal file and hands it off to Amazon SES, our mail carrier, who zips it off to the attendee's email. The absolute second that invite is sent, our postal worker immediately goes back to the DynamoDB logbook. It creates a brand new entry, marking down that this specific person has now officially been invited. At the same time, it can also update the overall event stats, maybe taking up the counter for total invites sent. And last but not least, cleanup. The invite's been sent, the records are updated, the job is done. So to make sure we never, ever accidentally process this same request again, the Lambda function deletes the original message from the SQS queue. This is what guarantees every single request is handled exactly once. Now for Section 4, the system's perfect memory. Let's really zero in on how that DynamoDB logbook is the secret weapon for preventing all those embarrassing errors. So what does this memory actually look like? Well, a record in DynamoDB is really simple, but it's incredibly powerful. It uses a unique key that's a combination of the event ID and the attendee's ID. This structure makes it super fast to check if, say, janedoe@email.com has already been invited to event #12345. If this simple entry exists in the logbook, no duplicate invite ever gets sent. It's really that simple, and that's how the system avoids those unprofessional mistakes. Okay, finally, let's pull it all together. Section 5, built for scale and reliability. Let's see how all these pieces create a system you can really, truly count on. A big part of that is how it handles problems. That potential disaster of sending duplicate invites? Solved. It checks DynamoDB every single time. But what if, for some reason, an email fails to send? Well, the system doesn't just crash or grind to a halt. Nope. It just logs that error for a human to look at later and immediately moves on to the next invite in the queue. The assembly line keeps moving. And the result of all this smart design? This is the big takeaway. The combination of that queue and that logbook means zero, absolutely zero, duplicate invites are ever sent, period. It completely eliminates one of the biggest and most common headaches of managing events. Now, this architecture is obviously fantastic for event invites, but the pattern itself is incredibly powerful. It really makes you think, doesn't it? If you could use a system just like this to reliably automate one tedious, annoying communication task in your own work, what would you pick?